symposium on reading emotions from facial expressions, implications for technology and health. And what motivated all of this, and what you're going to hear today, is a very simple question that we ask ourselves all the time: how are you? And if I wanted to get a detailed answer, I would sit down with you and have a chat. If I were a clinical psychologist or a psychiatrist, I might do a structured interview and give you self-report questionnaires. That takes time and effort, money in many cases. And here we're concerned with something much simpler, which is if all I have available, as mostly I do right now, a face. Some of you look perplexed, amused, annoyed. This is the question of this symposium. From just looking at a face, what can you tell about a person's emotion? And if you were to Google this on the internet, you would come away with the impression that this has mostly been figured out. So if you Google here, what I just did, I Googled the term emotional facial expressions, and you quickly get results like this that will tell you that there are 6 culturally universally recognized facial expressions of emotion. Here they are. And papers with titles such as Reading Facial Expressions of Emotion pop up, making you think that it's quite easy to read emotions just from the face. And companies have capitalized on this. Affectiva will tell you that they're able to detect nuanced emotions, complex cognitive states, and so forth. And so we, the presenters of the symposium, took stock of this something like 2.5 years ago. And after 2.5 years of a lot of disagreement, a lot of red ink, and a lot of patience with the lead author, by the lead author, and with the lead author, Lisa Feldman-Barrett, who really deserves a lot of the credit for instigating this. We came up with this tome of a paper here that is published in Psychological Science in the Public Interest. That's the journal. It's freely publicly available. You can download it there, and you can see in great detail what we will give you a summary of today in this symposium. And what we found out is that it's much more challenging than folks at Affectiva would lead you to believe, or that than you might be inclined to believe from just casually perusing the internet. And it can be illustrated very easily from an example here. If all you have available is information from a face like this, the face is ambiguous with respect to the emotion. It might look like sadness to you, but it can be disambiguated when you give it context and you see that the person is in fact experiencing some kind of ecstasy instead. And similarly here, while this might look like an expression of anger, you see it's just due to the fact that you have to make a very big mouth in order to wrap it around a watermelon. And again, if all you have available is this, there are many different emotions that are compatible with a single facial expression, and there are many different facial expressions compatible with a single emotion. So it's a many-to-many mapping. So the answer to this question, there's 3 important points that are going to pervade what you'll hear today. So the first question might be just how good are you at this, which you could assess with tests if you were administering to healthy participants in a psychological study or psychiatric populations, or if you're interested in training machine learning algorithms, you're worried about things like precision, specificity, and the problem is that this is very unreliable, in part because of the great variability that I showed you. There's a many-to-many mapping between emotions and between facial expressions. The second problem is the one that I just showed you the example of in the pictures, which is if all you have available, if all the features that you're feeding into your machine learning algorithm come just from a face, this is ambiguous, and you need to provide context. Now, modern psychologists, many of them, and people working in AI, are acutely aware of these challenges. But even when you surmount these 2, there's a third one that's very difficult, which is what is it actually that you're classifying? And at best, you can generally classify something for which there is public consensus. So people might agree that a certain face looks angry or afraid, etc. But even that's problematic, as I mentioned. But that's different from the ground truth of how the person actually feels. For instance, most of the stimuli used in experiments that assess recognition of emotion from facial expressions are not people genuinely experiencing an emotion. They're actors that are posing these facial expressions. Just to drive home this last point, this is not something we will speak about in the symposium, but of course, we make efforts to infer emotions not just in one another, but also in our pets and other animals. And Charles Darwin, in his seminal work, The Expression of the Emotions in Man and Animals, noted that animals have emotions. Animals have behaviors that are causally linked to those emotions, but figuring out what emotion this is extremely difficult. Dogs roll over on their back and like to have their tummy petted when I meet them. They seem happy to me, but they don't do that to one another. It's a sign of submission, and so maybe they're feeling submissive or even afraid rather than happy. So the question of actual validity, what is the actual emotion state that might go along with some facial movement, is an extremely difficult one. So to summarize just this brief background, this is a very challenging question because it requires inference. You don't have direct access to the internal states of another person, like emotions. You have to infer them from faces and context. It's unreliable, it's context dependent, and it's often not valid. And so in the next hour and a bit, what we're going to have is a series of talks. These first three are all going to be 20 minutes each, and if there are pressing questions, especially of clarity from any of you in the audience, we could just take those right at the end of each of these. Seth Pollack from University of Wisconsin-Madison will tell you that we're not born making adult expression, and certainly not born being able to recognize and classify emotions, let alone have words for them. We learn that. How do infants and children learn this? Alish Martinez from Ohio State University will tell you that when we walk around outside the conference center here, you don't see the kinds of expressions that people often use in tasks in psychology experiments, so-called prototypical emotional facial expressions. You see something much more nuanced. How do we understand those facial expressions in the wild? Lisa Feldman-Barrett will return to an important point that started all of this really, which is the seminal work by the psychologist Paul Ekman, who studied facial expressions in other cultures. And Lisa will tell you that this is very difficult and tricky to figure out and looks very different from the way that many of Paul Ekman's original studies are now interpreted. And then finally, Stacy Marcella, both of these are at Northeastern, will summarize and talk about the implications for AI and for virtual humans. And then we'll have some Q&A at the end. But again, at the end of each of these, if there's time, we can take a few brief questions as well. So I will hand it over with that to, I'm going to start this over each time anew so that the speakers can see how much time they have left. Okay, Seth Pollack will tell you about probabilistic learning of emotion categories in children.
Thank you, Ralph. Hello, everybody, and thank you for coming to join us this afternoon. I'm going to start this discussion with children because early in development seems like a good place to start a discussion. Where do things come from? What do we have at birth, and what do we start acquiring early in life when it comes to learning about emotion? Now, there are some very good reasons to start addressing this question with regard to children. And the primary benefit of looking at young children and infants is that young children don't have filters. They, as many of you might know if you've been around children very often, they haven't been socialized, they haven't learned to be polite, they don't understand what the cultural rules are for what should be expressed, how it should be expressed, when it should be expressed. And so one advantage of looking at children is they're just having their emotional lives, and whatever comes along with that comes along with it. And in some cases, one can argue there's a purer sense of the early brain and emotion in youth. But children also have some challenging things about them when it comes to studying emotion. One challenge is, how do we really know what a baby is thinking? We can't. It is like the anthropologist Alfred Kroeber called the "if I was a horse" fallacy. We're not a horse, and so we can't figure out what a horse would be making of a situation. And the same is actually true for human infants. We can't put ourselves in the situation of knowing what a baby perceives and understands and remembers. It's very difficult then to know prior to language, especially what an infant emotional behavior might mean. And so what we're left with are inferences that adults make based on observing babies and young children in various situations. And that's fine, that's completely appropriate. The problem is only when, as scientists, we forget that we're making that inferential leap between what we're observing and what we think a baby might be experiencing. Now, Ralph showed you earlier some of the pictures of facial affect. This top row are the pictures published by Paul Ekman in the 1960s that have been taken for many decades to be the core basic emotions that humans express. And these are proposed to be the baby versions of those emotions. And you hopefully in the next 10 minutes can decide for yourselves whether you think that these baby facial movements are basically reflecting the same thing as these adult facial movements. Now, sometimes it looks like it might be easy. So for example, you might think that the facial configuration on this adult and the facial configuration on this baby look actually pretty similar, and you might feel like these two people are really feeling the same thing. But I will return to that because maybe not. On the other hand, some might be more complicated. So for example, we can ask, are these people feeling the same thing? Does this look frightening? Is the baby frightened? Is the adult frightened? Yeah, probably, maybe, I don't know. Or is this baby and this adult feeling the same thing? Or maybe this is the same thing? Or this one? You can see that it actually isn't quite that easy when you line these faces up next to one another to try and make interpretations about what sort of internal state might be happening. Now, the reason for that is a long-standing problem in developmental psychology, which is what children can do and what they know and how they feel are not all the same thing. In terms of the first two, in developmental psychology, this is called the performance competence distinction. Babies don't have good motor control, they don't have language, they have very limited ways of showing us what they know, but we know they know a lot. And so this problem highlights the fact that babies might very well be thinking about and understanding things that they can't show us in a psychological experiment. But none of the experiments that are meant to address the performance competence distinction have really addressed how you figure out what a little baby might be experiencing in terms of emotion. There's common sense intuitions, and then there's objective evidence, and that's what we discuss in this paper. As I said earlier, most of what's happening in these studies are adults making assumptions about what a baby must be feeling based upon what's been presented to the baby in an experiment, and assuming, well, this is how an adult would probably react to this situation. One of the problems that we experience, though, when we look at baby facial movements is that a lot of the facial movements that babies make are actually not tied to emotion at all. They're really just an artifact of little faces with developing musculature moving. So for example, when babies get very aroused, brainstem activity, that will actually cause their lips to curl up, which we might think of as being an adult smile, but it's really just a sense of arousal. When babies open their mouths, that actually makes their eyebrows go up too, and sometimes people think that that's a surprised expression, but it's really just a function of the baby opening his or her mouth. When infants are about to cry, they open their mouth and it actually causes their face to change such that it can look angry, but it's really just these muscles all moving together. So it's just an example of the ways in which we have to be careful about the assumptions or interpretations we make based on facial muscular movements. One of the famous studies from many years ago in psychology that has really made its way into the literature, it's in introductory psychology textbooks, was this idea that by 24 weeks of age, babies understand the difference between happiness and anger. And this conclusion was based on a procedure that's called the habituation procedure. What habituation means is that babies will look at a stimulus, and when something changes, babies will get bored. They'll keep looking until they're bored. And then when something new happens, their interest peaks again, and they'll start paying attention. And so if a baby can detect a change, that means that they see a difference between two different kinds of events or categories or stimuli. And in this study, they found that 24-week-old infants actually could discriminate between these two facial movements. And they did it the other way too. They made them bored of one of them and then showed one, then they switched them. And in both cases, babies were very clear that they saw these things as being different. And this was hailed as little babies understand happiness and anger. There's a problem though. And the problem was there's a confound in the study. The confound was this. Babies very clearly could tell the difference between these two faces, but not between any of these pairs. And you can see that one of the confounds in the very first study was whether the mouth was open or closed. And so all babies were doing in this case was looking at a perceptual change. They were looking at the whiteness of teeth and noticing that change. They weren't looking at the whole face. They certainly were not making categorical distinctions about an emotion concept. They were just looking at a perceptual feature that had changed, and people were interpreting that perceptual feature as saying something deeper about understanding of emotion. Even when we look at something like smiling, which many people interpret as a baby feeling happy, in fact, there are a whole host of reasons that babies actually move their mouths such that the corners curl up. And those range from everything from having gas to having some sense of arousal to being interested in something. And so again, the point here is just interpretation has to be done in a very cautious way. I want to give you an example of this that's a little bit delightful. What I'm going to show you is a video that I found on YouTube. What is happening in this video is apparently this baby's father had been applying for jobs and received a rejection letter. And he is holding his rejection letter, and he rips it in front of his baby. And you can see how the baby responds. All right, this baby would have loved Nancy Pelosi at the State of the Union, right? It's very easy to look at this and say, this baby finds this just hysterical and delightful. But probably what's happening here is we have to remember a baby of this age does not have object permanence. Baby doesn't understand ripping. Baby doesn't understand what paper is. A baby at this age doesn't understand that something continues to exist when you don't see it. The equivalent would be my holding this laptop up in front of you, a weird sound happens and all of a sudden there's two laptops. How would you respond to that? You know, what's happening here is the baby is very aroused, interested. Something weird is happening in her environment. She's dealing with that arousal in the way babies do by creating this kind of smile and laughter in the same way that many of you at times have maybe laughed nervously when something weird or unusual has happened and you're just responding and you give out a little bit of a chuckle. And so one of the problems here, again, this illustrates is there are many reasons why babies could be moving their faces and doing things. It might not be the same interpretation as with adults. What babies can do, and do very reliably, is show adults that they're distressed. This is sort of a primitive alarm system, and babies seem to toggle between the state of quiescence, everything's copacetic, we're fine here, and then things are not okay. But the difference between reasons why things might not be okay is not something that babies convey. They don't do something different when they're hurt or hungry or tired or scared or any interpretation we might make. They really just show that all of a sudden they're distressed for whatever reason or they're calm. And this is great because adults then can respond, and then adults can actually hypothesis test about why the baby appears to be distressed. Later, as children get a little bit older, humans do start to move their faces in different ways, but again, adults cannot reliably distinguish what the internal state of the child is. And for example, if you look at the picture of this little boy, if I told you that he had just fallen down and gotten injured, that would work. If I told you that his parents were about to go out to dinner and leaving him with an unfamiliar babysitter and he really didn't like that, that would work. If I told you he was overtired and it was starting to melt down and his parents felt like it was time for bed, that would work. If I told you he had wanted a second cookie and his mother said, no, you can only have one, that would work. there's just no specificity there in what little kids do. And without understanding the context within which this is occurring, you can't actually make an accurate interpretation about what this child might feel. In terms of things like fear, which is written a lot about in the literature, it turns out that that prototype of the frightened, scared face that's discussed a lot in the adult literature, not observed in children. Children actually don't make the prototype fearful face. What we see in children are kind of one of two general configurations when they appear to be in a state of insecurity, but it's kind of a mashup of being fearful, sad, mad, distressed, fussy, frustrated, tired, disengaged. And this is something that, again, parents have to interpret based on what they know is happening in the situation. In my laboratory, what we've been doing is some work to try and understand how children start learning how to make inferences about what other people are feeling and start to signal what their needs to other people. And we've been focusing on how children learn to make inferences based on social cues that happen in their environment and how they grow and learn from errors they make in the kind of inferences and interpretations that they've been making. Now, one of the things that I wanted to show you is a study that illustrates the importance of learning here. One of the original problems with emotional development is people argued that emotions are so complicated and move so quickly and have so much meaning that if humans didn't already have some kind of basic bias towards emotions or basic understanding emotions, humans would never be able to learn this system. But now we're learning across domains that human infants are actually very powerful learners, and adults are very powerful learners, and people can break into very, very complicated systems of communication. In this case, we presented children and adults with various scenes where there was a facial movement and some kind of contextual information. In this case, if you can't see it well, there's someone in an airplane seat and a child behind that seat kicking back and forth, and I'm sure many of us have been in that situation. What's interesting here is we recorded the live eye movements of children and adults while they were presented with scenes like this. And we found something that was very interesting. First, in terms of adults, they kind of made a quick glance at what was happening in the context. But they looked at the context, they made their interpretation of what that person was feeling based on the face, and they stayed there. It's almost like adults feel like, I know the face isn't perfect, but it's good enough for this experiment. There's very little risk for my making a wrong interpretation here. And so adults kind of go through the experiment by just kind of looking at the face, making a determination about what that woman might be experiencing, and then moving on to the next trial. Children, on the other hand, not only equally divide their attention between the face and the context, they keep moving back and forth. And if you were to see sort of a live clip of what's happening, they look at the context, they look at the face, they look at the context, they go back to the face. It's almost as if children do not yet think that the face is actually a reliable index of what's going on. They're still learning that, and they're hypothesis testing and going back and forth to try and integrate and learn what's happening in a face and what's happening in an environment. Similarly, in terms of learning, we've done some work many years ago showing that people actually can learn how different kinds of facial movements are categorized. In this case, we found when we morphed faces from a very threatening, scowly-looking face to a neutral face, that most children actually see the difference between these two between the series of faces right about in the middle there. So everything on the right side, they view that as being kind of that person looking threatening, and they don't see much difference between the faces on one side, and they group and categorize lack of threat on the left side, and they don't perceive there's very much difference between these faces. But when we do this exact same procedure with age-matched children who have been living in abusive situations and violent situations where their caregivers, the people that are supposed to be protecting them, offering security, are actually threatening or actually harming the children, then the way these individuals form the categories is really quite different. And these children now view everything that's to the right of that line as indicating a sign of threat. Those small differences in some of those faces they've learned are actually a very meaningful cue that they use in determining what counts as threatening and what doesn't. Again, suggesting that social experience and learning have an important role in how we think about and conceptualize emotion. Now, there are basically two different hypotheses about how children can go about learning what different emotions are and what they look like. One of them from the machine learning literature is called supervised learning. And supervised learning is really just a fancy way of saying we tell people. And it's very hard to go into any US preschool and not see these posters where we actually present prototypes that are not right for all the reasons we're going to keep talking about over the next 30 minutes or so. But we actually tell people this is how you're supposed to look when you feel these things. And we read them storybooks that actually don't really map on to what people do in their everyday lives all the time. And this sort of is information. Teachers and parents and books and posters are telling you how you're supposed to move your body when you feel certain things. But it turns out that there's very little evidence that this accounts for that much of how people actually make sense of their worlds in childhood. Instead, children are engaged in all kinds of interactions with different people, in different contexts, with the same people, feeling different things in different contexts, and somehow children have to extract from all of this information what is the core information that's most salient and most important to attend to try and make one of these kinds of inferences. And that's actually a very challenging learning problem, but it's also nuanced and adaptive and the best way to actually start to navigate the social world. We tested to see how children were actually able to do something like that. And we did this with a little paradigm here, where again, we took faces and we morphed them from a threatening, scowling-looking face to a neutral face. Children didn't see that. This is just a caricature of the kind of stimuli they saw. But different faces along the stimulus array were presented to children one at a time. And children were told, this is Jane. We didn't use any emotion labels. We just said, sometimes Jane feels very upset. And when she's upset, she likes to go to her red room and hit a punching bag. But sometimes she feels very calm. And when she feels calm, she likes to go to her blue room and read a book. Children were then presented with these different faces sampled from across this array. And here are the two tricks that made this experiment interesting. The first is, in one condition, we actually corrected children. We told them what counted as upset and what counted as calm. And if they classified things the wrong way, the computer would say, no, you're wrong. That's not a red room, Jane. That's a blue room, Jane. Or that's not a blue room, Jane. That's a red room, Jane. In another condition, we didn't give any kind of feedback at all. We just let children move these faces and categorize them as they wished with no kind of feedback. The second thing we did is all of the children did not receive the same kind of input. Instead, 1/3 of the children received a sampling of faces that was just towards the scowling face end, and they were sampling towards one end of the distribution. Another group really only sampled faces towards the more neutral, less facial movement end of the spectrum, and then a third group sampled the whole range of stimuli. What we found is that when we told children what the right and wrong answer was, they figured it out really fast and they did it. In fact, they did it within 8 trials. So children used that information very clearly. They were very smart. This result isn't very interesting. All this says is when you tell people what the right and wrong answer is, they'll do that. More interesting is, how did the kind of experience that children had in the experiment, given the range of facial movements that they saw, influence the children's categorization of these facial movements? And here, this was fascinating. What happened was, when children actually were presented with a lot of scowling faces, then they actually formed a boundary where some of the scowling faces that were less scowly, they thought that was calm. Whereas when children saw faces that were in the relatively neutral range, faces with just a little bit of movement in them, they determined that that was upset. And so this happened within 12 minutes. And so you can imagine if people can start to change their categorization about how they think people feel based on 12 minutes of exposure, how does having a lifetime of meeting different people in different contexts, in different situations, start changing on a real-time basis how you are making inferences and interpretations about what might be going on for somebody else? And this is a very good example, I think, of showing the powerful and fast learning that humans are able to do based on the input that they're provided with. So let me wrap up. One takeaway message here is that infant facial movements tend to be overinterpreted. A lot of things happen for physiological reasons. A lot of things happen for completely different reasons. But adults see a similarity to prototypes with adult movements and maybe overinterpret what an infant is actually doing. A second takeaway point is that young children's emotions tend not to be very distinct. And so adult observers have a very hard time making inferences about what children might feel without any kind of contextual information and understanding of what's going on in that situation. And the third take-home message is that children and adults are very powerful learners, and based on the real-time experiences that we have interacting with people, we can actively start to construct different interpretations of what might be happening rather than making generalized generalized conclusions based on prototype features. So I went very quickly. All of the work that I've talked about is freely available on this website. And some of the emerging new papers are available on this Twitter website. And I'll also say this is a scientific Twitter. This website is only for science and release of new papers. It's not my opinions about everything or my arguing with people. So with that, if you want more, please go and look it up. And I will now turn it over to Professor Martinez. Thank you.
Okay, great. Thank you very much. So the next speaker is Alish Martinez from Ohio State University. He's going to talk about recognizing emotional expressions in the wild.
All right, thanks, Ralph. So as Seth has already mentioned, facial configurations, or what I'm going to call facial configurations, are created by moving your facial muscles. And the reason that there's been so much interest on this, because even from the very start of science and philosophy, for example, the Greek philosophers at the time of Aristotle, they had already written manuscripts on the importance of facial muscles and the expression of emotion. So the hypothesis here is that when we internally experience an emotion is nothing else as your brain or your central nervous system executing a number of computations, depending on which type of external or internal input you have, that some of these computations are actually leaked into your facial muscle movements, and that therefore, by just looking at how you move your facial muscles, you can do reverse inference and determine what the internal emotion of that person is. This was popularized mostly by Darwin, but its work was mostly popularized by Darwin, but that's work mostly done by Duchenne, who was a famous French neurologist of the time, and wrote a fascinating book. This is him, Duchenne, on the right-hand side with one of his patients. The way he showed this is by anesthetizing the face of the patients, if you can believe this, and putting electrical probes into those patients to activate the facial muscles. So they look like they're making an expression and they're taking a photograph of that. This is, to my knowledge, one of the very first books, scientific books, to ever include pictures. It was at that time when photography had just been invented, electricity, of course, so you can imagine why this patient had to be anesthetized, because it must have been extremely painful to have these electrodes on your face. So based on that hypothesis, this hypothesis has been modulated over the years. Descartes had a few things to say earlier, but as I said, Duchenne just basically gave a very good description of the facial muscles that are involved in these facial configurations. And then Paul Ekman and many other psychologists have argued that there's these so-called basic universal expressions like happiness, surprise, and fear that correspond to a very specific set of facial muscle articulations. So the hypothesis, again, is that every one of us uses the same facial muscle articulations, generally called action units or AUs, to express the same emotion category, and that these AUs are different across emotion categories. Now, the question is whether the brain actually interprets this by interpreting that emotion category that I have mentioned, or it actually interprets the facial muscle articulation. So to test this, we actually ran an fMRI study a few years ago, where we showed images of facial configurations to people like the ones that you see on the right-hand side. And you can see that, for example, action unit 1, which is the muscle that raises the inner corners of your eyebrows, is seen in a multitude of expressions. Action unit 2, which raises the outer corner of your eyebrows, it's seen in another multitude of facial expressions. Action unit 12, it's seen in another set of facial expressions, and so on. So we set out an experiment such that the subjects in the fMRI saw half of the image that they saw had one of these AUs active, and the other half did not have that AU active. But at the same time, another half of the images had one of the emotion categories, and the other half did not have that emotion category. And the question is, which one could you decode using machine learning algorithms from brain activity, from bolt activity? And the answer was that we could detect very reliably the action unit that the human subjects in the fMRI were looking at, but we could not detect the emotion category. So here are shown the results for action units. You can see here for these different AUs that especially in PSTS, which is the area that's involved in biological motion analysis, there is a clear, good classification of the action units that I have mentioned. But when we used the same approach to study emotion categories, we found absolutely no signal. This is the area of the brain, just in case you're curious, on the right-hand side of your brain, just this little area that is actually constantly decoding the facial muscle articulations. Now, this is interesting because, as I mentioned, the brain seems to be decoding this facial muscle articulation, which occurs in a variety of facial expressions. That may seem weird that we decode facial muscle articulations rather than emotion categories, but let's face it, you can detect any possible facial muscle articulation that you have ever seen, even if it carries absolutely no meaning. We have about, depending how you count them, about 40 muscles in the face, which means that you can generate 2 to the power of 40, which is several million facial configurations. So obviously, if you had to have an algorithm that detects all these millions and millions of facial configurations, it would be extremely costly. It would take most of your brain just to do that one task. Whereas identifying 40 different muscle articulations and then putting them together to do an interpretation is a much easier way to solve the problem. So that's why we and many others have designed computer vision algorithms in machine learning that can actually do the same thing. And these algorithms are specifically designed to detect how your facial muscles move on the face, and that allows us to do analyses like this. This is a video that some of my students found online. These are actors moving their faces very slowly. This is not a slow motion. It's actually real time. And you can see the algorithm is detecting these action units automatically. AU12 is the corner of the mouth moving sideways and up. It's a classical smile. 25, it's mouth open. 6 is the cheek raiser, and so on. And now we have these algorithms that computer vision algorithms that can do all this analysis for us. And these algorithms are really accurate for images like this. They're not so accurate for some other images for another discussion, but they're very accurate for images like this. And because of this, we have now been able to analyze millions and millions of images in the wild. So what we did in my lab, we collected over 7 million images of facial expressions from images from people of 35 different countries. So multiple cultures, multiple countries, ethnicities, obviously gender, races, skin color, etc., different cultural backgrounds. We collected all these different types of facial expressions that you can see on a daily basis in the wild, not in the lab. These are real images. These are people really interacted in the world. And the question is, using this computer vision algorithm that I just showed you, can we detect facial configurations that are used across all these different cultures in these 35 different countries? And the answer is surprisingly yes. We have identified 35 of them. Probably there are more, but at least there are these 35 that they are used across all these different cultures that we tested. Interestingly, 17 of them would be classified in what we'd say, if we were looking at the prototypical classification, happiness, meaning positive emotions. 5 would be classified as types of sadness, and so on. And you can see all of them here. The question is, now, this is what production looks like. This is the production in the wild of people across cultures trying to communicate something to others, apparently. What is the reading that the people in these cultures have when they look at these images? That is to say, if I show these 35 images to people from these 35 different countries, are they all going to interpret these images equally? And the experiment is very simple. You just show one image at a time, and you allow people to give a label to these images, actually allow them to give 2 labels, right, if they wanted to. Completely up to you, no restrictions, whatever word comes to mind. And this is the results of the analysis for the 35 images, some of them. And you can see that there is a clear categorization occurring, right? So for this number 1, most people say sadness, right? And for this number 2, most people say sadness as well. Let's see, for this 9, most people say happiness, right? And so on. So there seems to be some type of categorization going on, but the important point here is not on this, but actually the disagreement. Yes, there's a statistical significance between the top choice and the second one, which gets you a publication, but this is at 20% accuracy, right? So meaning 20% of people think that this face looks sad, 80% think it doesn't look anything like sad, right? It looks something else. This one is probably about 42%, right? And so on. You can see this is another 25%. These are more examples here, 50%, 15%, maybe 17%, right? 22%. You can see that the percentages, so there is agreement in the population, but the percentages are just too low to specifically determine that every time you see that facial expression means X. It means X in a very small number of conditions. And the question then that we have to ask is, why does this happen, right? Why do we see this disagreement among the population, like 80% saying this doesn't look sad when 20% agree that it does? And the reason is that there are many variables that we use to recognize facial configurations and facial expressions. So I'm sure most of you are familiar with Wood's American Gothic, famous painting. There's these 2 farmers, and the male character that I'm showing here has a really, really, really sad expression. But if you look closely, this person is actually expressing absolutely nothing. His facial muscles are completely at rest. There is no expression, no intent to communicate any emotion. Yet we still perceive sadness. And the reason for that, we've shown in our research that this is because your brain, the algorithm that you have in your brain to interpret these images, actually computes what's called configural features, which mean the distances between different facial components. And in particular, there is one that computes the distance of the baseline of the eyebrows to the baseline of the mouth, and another one which is the width of the face. Okay? And if you tend to have a really uncanny, like this guy, long face, it might sound familiar, and thin face, you look sad all the time, no matter what you do. Whereas if you have to tend a short distance between the brow and the mouth and a wider face, you tend to look angry. The bulldog comes to mind when we overgeneralize to animals. So a student of mine, with the help of a morphing software, did just that, decrease the distance between the brows and the mouth, increase the width of the face, and now the guy looks angry. So I would say if this guy had been living in the McDonald's area, fast food, the painting would have been like this. A few years ago, I was in Barcelona in a museum of Romanesque art, and this is art from around the 1000 CE, and I was interested about these paintings because they also have the same long face description to emphasize this sadness effect, right? And that's at the time when painters didn't know how to actually paint good expressions. So to them, the expression was a long face, was not necessarily a curved mouth. Another reason why this is difficult, why people disagree in this classification of emotions, is because faces are not the sole communicator, a nonverbal communicator that we use to interact with one another. Body pose, obviously, it's another, right? So if you look at this body pose, you think that this is someone that wants to punch you. If you look at this body pose, you think there's someone that wants to get away from you or is afraid from you. But then it depends, right? You can combine certain body pose with expressions that are congruent with what I just said, or you could have facial expressions that are incongruent. So depending on the facial expression, although this looks submissive as a body pose, if I put the specific facial expressions, it can actually mean that I'm threatening you, right? And to give you to run an experiment here very quickly to show you how important this is, I'm going to show these two images, and you can tell me what you think about them. But when I show them to human subjects, people generally agree the image on the left represents anger. I mean, this guy looks that he's going to kill someone. Absolutely, really angry. The girl on the right looks super sad. I mean, something really bad has happened to her. Both of them have a very negative valence, a negative expression, or a negative emotion. But when you see these images in context, there's a different story, right? They're all positive emotions, very positive. The guy on the left, a soccer player, just scored a goal, celebrating. And the girl on the right probably looking at an idol, music or whatever, movie star. And she's actually really happy, right? These are tears of happiness. So the context, as Seth mentioned earlier, is another very, very, very important variable. So much so that in many cases, it is actually easier to extract the emotion that these two people are experiencing based on the context alone than just trying to extract the emotion that someone is experiencing based on the facial expression. Here are more results on this. This actually explains, right, why some people, when looking at this face, they'll say, yeah, it's probably angry, but I can see in some context that people would think that this is a fearful expression, or maybe a sad, when something bad happens to you, that it's a sad, say someone has passed and you were told that information, I could clearly see that expression representing sadness, right? So there are all these different types of interpretations depending on body pose, context, and so on. So to summarize this, not everyone who smiles is happy, and not everyone who is happy smiles. People can lie as well. We're good liars. We're not the only animals that lie, but I can certainly make you believe that I'm happy when I'm not, and I can certainly mask my expression when I don't want to show any expression. But even beyond that, many times you have been happy, maybe for many hours, right, at different intervals, and you have not been smiling at yourself all the time. You just don't do that, right? So people don't always smile when happy. Same for the other expressions. Other things that why people may disagree in the classification of these expressions in the wild that I've mentioned is because we are discovering there are many other variables we didn't even know existed. One of them is facial color. So it turns out that obviously when you experience an emotion internally, or you go through a variety of daily chores, there are some changes in your brain, right? Your brain's executing a number of computations to keep you from getting harmed and to actually achieve the task that you want to achieve. And that actually releases a lot of peptides, the most commonly known are hormones. And the release of these hormones actually change the blood flow and blood composition in your body. And because the face turns out to be innervated with this huge number of blood vessels, your face actually pulsates in color. So we can actually detect when people are releasing these peptides and hormones just based on the facial color. And when you show these facial color changes to people, you can tell me which of these two looks like the genuine smile and which of these two like the genuine anger. So when we run these different experiments with people, people are actually very good at recognizing these changes. This actually is the facial expression with the facial muscle articulations of what would be a prototypical happy expression, but with the colors of what would be a prototypical angry expression. And people are actually very sensitive to this. When you show, and obviously the colors in this type of monitors is not the best, but if you want to look at it in my computer later on, when people look at these colors, or this image, excuse me, they just make no sense to them. They know that there's something amiss. So these things occur all the time, depending on how we interact with people. And these are cues that we are using constantly. We just don't know whether we are using them. And now that we are learning about these things, we understand also why people have different interpretations within different contexts and within different variables. And maybe another variable I'm going to talk about that is very important in the wild is biological motion. So you have here an example of not even bodies, let alone faces, of objects that clearly describe the behavior of someone being really afraid of someone else, but following the instructions, versus people probably just enjoying life and being happy in the park. So these different types of biological motions are very important, and there's very little literature still in understanding how we use these variables, how these variables are encoded to interpret human emotions. So to summarize, the early hypothesis was that there are going to be some brain cells or ROIs in the brain that are activated when we see specific emotion categories like happiness, sadness, surprise, and so on. But when we look at the brain, we do not see that. Instead, we actually see activation of cells or ROIs that are sensitive to the facial muscle articulations, not the emotion categories. And most likely, we have a set of dimensions in our computational space in our brain that interprets facial muscle articulations, color changes, as I've mentioned, body pose, kinematic information of the body motion, contextual information, and so on, situational, cultural norms that we have learned, et cetera, and based on all this, we make an inference on what we believe someone is experiencing, not just by just analyzing the face quickly. Having said that, there is very little knowledge still on all these steps, so we have a long ways to understand fully how much of these variables influence the way we interpret emotions, or in fact, how good that information is to infer emotion. So before I pass the torch to Lisa, I just want to say thank you to my students, because obviously, as you know, these are the people that run all the experiments, and they do all the work, and obviously our funders. Thanks.
I do want to say that working on this paper with my colleagues really actually was one of the best scientific experiences I've ever had in my life, in my entire career, really. This really is up there, right? We are come from very different theoretical perspectives. We all had very different hypotheses at the outset of what we were going to find. We did debate quite a bit, but it was fun, and no one was defensive, and everyone was willing to admit when they were wrong about the interpretation of data. And so while we're thanking funders and students and so on, I have actually all 4 of them here in this room, so I'm just going to thank them now, as opposed to at the end of my talk when I'm going to be rushing, because I too will be over time. Brevity is not my strong suit, so I'm going to do my best. My job today is to talk to you a little bit about where the idea comes from that we have universal expressions of emotion, the idea that everyone scowls when they're angry and smiles when they're happy and frowns when they're sad, and so on. It's true that these ideas come from, actually they were been around since ancient Greece, and every culture has its own prescriptive universal expressions that don't necessarily agree with Darwin's. And there's a really interesting story about how Darwin came to these ideas to begin with. But for our purposes today, we're really going to start with the empirical literature in its modern form, which begins really in the 1960s. And most experiments which study whether or not emotional expressions are universal use a method like this. So it's not actually, most of the evidence doesn't come from observing people as they move their faces in everyday life. Most of the evidence actually comes from what we would call perception studies, okay? Or they're sometimes called recognition studies, but that's inaccurate because as several of my esteemed colleagues have pointed out, the people in these photographs are not actually feeling anything. They're posing facial configurations. And I also want to point out, I don't really think of these as prototypes. I think of these as stereotypes, actually, of expressions. But the standard method that's used in these experiments is to show test subjects a face, give them a set of words, and ask them to pick the word that matches the face. So which word matches the face? Thank you. Angry. And when you do this in experiments across cultures, and we're talking here about urban cultures, large-scale urban cultures, you see an average agreement of 67%. So 67% on average across categories and across people and across all of these cultures, 20 or so cultures that have been studied, large-scale urban cultures, you see an agreement of 67%. Sometimes this is called accuracy, even though, as I said, they're not actually experiencing anything. It's really just consensus or agreement. This is what scientists would consider strong evidence of universality, actually. And this method is called a choice from array method, or a forced choice method. It's called a choice from array method because you're given a set of choices and you pick one. The other version of this, which is sometimes used cross-culturally, is to tell a little story, like Bobby's dog died, Bobby is sad, and then to show people two faces or to play them two vocal poses and ask subjects to pick one or the other. That's also a choice from array task. And as you're going to see throughout this talk, it's really important to understand the exact method that's being used here in order to understand what the evidence means that comes from that method. So hundreds of studies give us, almost 100 studies actually give us this statistic. The thing is that when you remove the words and you just ask subjects to freely label the faces the way that Alish described in his study, you see something different. What you see, this by the way is called free labeling, and what you see is that average agreement levels plummet to very, very weak levels. And in some studies, for example, studies that are focusing on the category contempt or shame or embarrassment or compassion, the agreement rates drop to chance levels. So this is what happens when you remove words or any kind of context and you just show a face and you say, please tell me what you think this face means. So what happens when we take this method and we go to very remote cultures that are small scale and have very, very limited access to Western cultural practices and norms? This is considered to be the gold standard evidence of universality, okay? For almost 40 years, claims of universality were based on 2 peer-reviewed papers, which reported on 4 samples that were all from Papua New Guinea. These are the famous papers studies conducted by Paul Ekman. And so what Paul and his team did was they did something actually really remarkable. They schlepped a bunch of equipment into Papua New Guinea. They tested the samples of subjects there. And what they did was they used this choice from array method. Basically, in 3 of the 4 studies, they used a choice from array method where they told a little story, showed 2 faces. So, Bobby's dog died, Bobby is sad. And then they show a smiling face and a frowning face, and they ask subjects to pick which face matches the story. And found, so 3 studies used this very constrained forced choice or choice from array. 1 used free labeling. 3 studies found evidence, very strong evidence of universality, and 1 didn't. And can you guess which one was which? Right. Okay. Since 2007, there have been lots of other studies conducted in remote cultures using a variety of methods that are choice from array and free labeling, and plus a bunch of other methods as well. They largely don't replicate the original Ekman studies. I'm just going to talk to you a little bit about one study that we conducted in Tanzania, the Hadza of Tanzania. The senior author on this study is Maria Gendron, who's now an assistant professor at Yale University. And the reason for testing the Hadza in Tanzania is that they are a small-scale hunter-gatherer society who are semi-nomadic. They're not an ancient culture by any means. They're modern humans, but they live with a foraging lifestyle that is very similar to our Pleistocene ancestors on the African savanna. And they live under circumstances and in social groupings that are hypothesized by evolutionary psychologists to be the conditions in which these expressions evolved. They have some of the oldest mitochondrial DNA on the planet. And I should also point out that there are only about 150 of them left. They are rapidly disappearing for a number of reasons. So we were really fortunate to be able to test these people. And when we use free labeling, I'm not even going to show you the forced choice method because the choice from array, because it actually gives us really really findings to the forced choice findings. Basically, we see 25% on average agreement across categories, where 17% is chance. Why above chance? Because there's one positive category, happy, and all the others are negative. So if we remove the positive category, we actually basically see chance levels. The reason why this is above, slightly above chance is that actually the Hadza use the word angry at higher levels of agreement, but they also have low specificity, meaning they basically rarely use emotion labels at all, but when they do, they use angry. And about 50% of the time, when you show them these faces, they don't even use what we would consider to be emotion words. They basically use words to label the state as a behavioral state in a particular context. So sometimes people ask me, well, how often do they frown when they're sad? And I have to say, that's actually not a meaningful question to these people. Even emotion words actually only entered their language, Hadzade, from Swahili sometime in the last century. So if we're going to summarize across all the studies that we have now that have been peer-reviewed and published, and I'm just going to do a gross generalization for the sake of time, we can see that there are 4 samples, 3 from the original Ekman studies and 1 other study published by Jess Tracy in 2008, I believe, which find strong support for, moderate to strong support for universal expressions of emotion, where test subjects are choosing labels choosing faces to match a story in a way that American test subjects would, who are usually the comparisons. But there are no studies using a free labeling method that find strong evidence for this. I mean, the most unconstrained, so part of the problem here, right, is that choice from array doesn't give you a lot of options to discover anything, right? You can't discover that test subjects would perceive these faces in any other ways other than the choices that you've given them. Whereas with free labeling, you can discover a lot. And there's really no evidence from free labeling. However, even choice from array methods can sometimes give you strong evidence of cultural variation. And certainly all the studies using free labeling do that as well. Now, you might ask yourself, well, I certainly asked myself, what's the difference between the studies that give evidence and the studies that don't from the choice from array? Like, if it's such a powerful method, how come we're not seeing consistent results here? And I'm just going to answer that question for you now. There's a really interesting story about how we discovered the answer to this question. And that is, one of the authors of a paper wrote a rebuttal to one of our papers and published it and revealed that there was something in the method that we didn't know about, that no one knew about because it hadn't actually been published. So in order to test whether this was actually manufacturing evidence that looked like universality, we ran a new study. With people from the Hadza culture. We sampled emotion concepts from a variety of cultures across the globe that have been deemed untranslatable into English by single words. And we verified that these emotion concepts did not exist in Hadzade, and they did not exist in English, and they did not exist in Chinese, which was the other culture that we tested as a control for in this. And in this study, what we did is we picked these 6 categories or emotion concepts. So here they are again. And we plopped them into the choice from array method to see if we could make them look universal. So basically, we made up emotion cues, and in this case, I'm going to present data from vocalizations because this is a study that we were attempting. We were addressing a study that had already been published. So instead of using faces, they had used posed vocalizations, so cries for sadness and screams for fear, and grumbles, grunts for anger, and laughs for happiness, and so on. And so what we did is we took these 6 categories and we just made up vocalizations. Just made them up. Sat around in a lab, made them up, plopped them into the method. So for example, for giggle, which is a category that comes from the Philippines that means an overwhelming urge to squeeze or pinch something that is very cute. So basically like all the babies that Seth showed in his presentation. So giggle, the vocalization we made up was kind of a squeal, like ee, ah, like that. You have to, to get it out. And so we just made it up, and then what we did is we used the method that we understood, the sort of secret piece to this. So here's how these studies actually get run. It's not just that you give someone a little story, present them with 2 examples, and then ask them to choose. First, there's a manipulation check period, which most studies don't tell you about in studies of remote samples, which goes like this. You ask someone, you basically read the little story to the person in the remote culture, your test subject, and you ask them to tell you what the story was about. So in this study, we told them the little story that we made up for giggle. Someone sees a small, chubby, lovely baby and wants to squeeze it tightly. They feel giggle. And then we say to the test subject, what was the story about? And they have to answer you in the American way, or in the way that American would understand giggle. And then if they give you the right answer, they pass the manipulation check, meaning they understand the category, and they can go on and do the task. And if they don't understand the story the way that you expect them to, you tell them the story again, and you ask them again to explain it to you. And if they don't eventually understand the story, you disqualify them from the study. So let me just be really clear. The original study that we were trying to replicate was by Disa Sauder et al. That was published in the Proceedings of the National Academy of Sciences in 2010. They did this study, but with anger, sadness, fear, disgust, and the standard categories. And they would ask test subject, they would tell a little story about sadness. Bobby's dog died, Bobby's sad. How does Bobby feel? And then the test subjects, in this case, which were the Himba, who we also tested, by the way, in another set of studies, which I'm not presenting today. They would have to tell you the story. They would have to tell you that the person was sad and explain what sadness is in an American way. And if they didn't, then they would be asked again. And after several times, if they couldn't answer the question, they were disqualified from the study. So now you have a set of people who understand the concept as you intend it to be understood in your universal way. And then here's how the studies run. You present someone again with the story, and you present them with 2 sounds, and then you ask them to choose. And then you present the same story again, and you present them with 2 sounds, and you ask them to choose. And then you present them with the same story again, and you present them with 2 more sounds, and you ask them to choose. So basically, on trial 1, they hear the story for giggle, and they hear the squeal for giggle, and a different sound. Then on trial 2, they hear the story for giggle, and the sound for giggle, and another sound, and so on and so forth. And then when you get done with that set of trials, you go on to another category. This is called blocking your trials instead of doing random assignment. Can anyone guess what's happening here? Sir, with the beard in the corner there? You asked a question of my colleague Seth. You asked about, do adults learn? What's happening?
I would say I'm totally confused, because I would have thought that you'd have to see the person that's trying to read an emotion would have to see the person's face and the activity that they're undergoing at the time in order to map properly how they might be feeling.
Actually, it turns out that all you have to do is give a story with a word, repeat it over and over with the sound, and subjects learn during the experiment that the sound goes with the word. And in fact, I think in Seth's study, it took 8 minutes or something in 8 trials. Here, it takes even fewer, because these are not children, they're adults. And so basically 5 of the 6 categories come out looking universal. They have agreement rates which are equivalent to what we see in the original forced choice or choice from array studies with anger, sadness, fear, disgust, and so on. So basically, we just manufactured evidence for 6 non-universal categories, so that have never been proposed as universal, to look universal just by virtue of putting them in this method. Now, just to wrap up, I'll say this. The problems with choice from array methods have been known for a very, very, very long time. This is a paper that was published in 1994, which laid out many of the problems, including the fact that the context that you present faces in, or voices, or any cues matters, because humans are pattern learners. If I present to you a set of faces that you've never seen before, and I present you with a set of words, and I associate them across trials, you will learn to associate them. There's actually a classic study now which shows that like 8-year-olds can do this in under 4 trials. The point here is that it's not that the original Ekman studies discovered nothing. They discovered something. They didn't discover that expressions were, that those stereotyped expressions were universal. They discovered the power of supervised learning with words. You can take people from a remote culture, show them facial configurations they've never seen before, map them to a set of words that they infrequently use across a couple of trials, and people can learn them and learn to associate them. On the one hand, that may suggest that, it suggests that the original studies were important, not because they demonstrated that we all scowl when we're angry and smile when we're happy. It demonstrated instead that context matters, so much so that we can actually use words to help teach people how to perceive emotion across cultures when they have no familiarity or very, very little familiarity with the signals beforehand. Thank you.
So I'm going to cut the talk short, just give you a sense of the technology and not maybe go into all the details here. What I want to talk about are these things called virtual humans. And essentially, so this is kind of a right turn from previous discussions or presentations we've had. Basically, the idea behind these virtual humans is that they're, instead of thinking about, say, studying human behavior, you're really trying to engineer human behavior. You're really trying to make an artifact that can engage people in a social interaction, and using the same sort of verbal and nonverbal behavior that we use when we interact with each other. And these artifacts are being used for a variety of uses, including playing the roles of teachers and peers and counselors. But I want to give you a sense of, how the issues that we've been talking about today impact the design of this technology, but also how this technology might be useful for actually exploring the kinds of issues we're talking about, how we can actually use this technology to explore the question of what do these facial actions actually mean. So just to give you a quick sense, and then at some point I should cut off because you guys won't have any time for questions. I want to show you an example of one of these virtual humans interacting with a person here on the left. The person on the left is pretending to suffer from PTSD, and this is part of a research platform that was developed to explore the question of, if the virtual human is asking specific kinds of questions, does it elicit certain kinds of verbal and nonverbal responses from the human that allow us to essentially assess, triage, or screen for PTSD? So let me show you how this system works.
Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself.
She's lying.
When was the last time you felt really happy?
When was the last time? I don't know. Yeah, I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just happy. I guess to answer your question, probably a couple months ago.
I noticed you were hesitant on that one. Would you say you were generally a happy person?
I'm generally happy.
So what's really happening there, essentially, is that she's asking questions. He's responding. He's also, we're doing facial action recognition to see what facial actions are occurring. We're analyzing the prosody in the voice. We're looking at what the gaze patterns, the posture, and the gesture is. And really, the question we're asking in doing this research is, do PTSD sufferers non-verbally react differently to specific questions than non-sufferers? And so if you put somebody through a standard PTSD screening, you can then see how good is this application in terms of a standard instrument for evaluating PTSD. Now, this is kind of just the tip of the iceberg. These things are being used in lots of applications.
Leukemia?
They're being used to teach doctors how to break bad news. They're being used in health interventions of various kinds. They're used in psychological studies. And they're currently, one of the projects I recently was involved in is creating an avatar for someone who suffers
This is a lot easier.
motor neuron disease. Sorry about that. So if you look at these technology, you realize, well, what's going on here is that there's a synergy between psychological research, which is the study of human behavior, and virtual human technology, which is the engineering of human behavior. In particular, what's happening here is we're taking data and theory about human behavior, we're incorporating it, computationally modeling it into these virtual humans, and then applying them in various kinds of applications, health and training. And one of the benefits of doing this is essentially like, well, there's also this back benefit to psychology, because in fact, we can now use these virtual humans in psychological studies where they can be precisely controlled, and we can collect data on how people respond to them. We can also put them into applications, and then once they're in an application, we can do data collection and analysis at large scale. What I want to very quickly go through, because we're down to 6 minutes, is I want to just very briefly touch on some of the issues that come up in this conversation, which really impact how this technology is created. In particular, if we look at somebody's facial expression, we realize, okay, we can't draw really strong inferences from it, because in fact she looks angry, but we all know this person, she's not angry. In fact, if you look at the larger context, she's actually just won her match. And the idea there is that, like in the PTSD example, you really want to look at things multimodally into this larger context, and maybe then you can make an inference. But the facial actions by themselves aren't going to tell you very much. There's also this question of variation is the norm. And so how does a virtual human deal with this variation? In particular, how do we actually create virtual humans that exhibit variation in how they express themselves? And also, how can they actually create these virtual humans in these training applications? If we're using them for social skills training, we don't want to train someone's social skills on a particular stereotypical behavior. We really want to show somebody, if we're teaching social skills, what that variation is. So we have to really think deeply about this question of variation. We also have to take into account that the behavior occurs in social context. For example, that clinician virtual human you just saw, she essentially was designed by us to really replicate a clinician's actual nonverbal behavior. So she has very soft gestures to calm the client down. And so really you have to understand that you want to model behavior within the context of a certain social situation. And then you really have to take into account that the facial actions have many roles in social interaction. So for instance, when that clinician smiled, she was not smiling because she wanted to convey happiness. She was smiling to build rapport. In fact, something like a smile plays an enormous number of roles in social interaction. And again, we have to think about this from an engineering perspective. I just want to sort of close out by saying these artifacts have potentially a wide range of impact that I see I'm very positive about. But I think we also need to take into account that we're embedding into the social reality these artifacts that can socially interact with us. And increasingly, it looks like they're going to be very pervasive, because large corporations are now involved in creating these kinds of virtual humans. And so really we have to look at them from the perspective of that they are either explicitly training or empirically, implicitly informing our social interactions. They could change us in some way, if you think about it. So let me stop there. Let me stop with these final comments of the research. The way I look at this kind of technology is the research needs to inform it, but also the technology can be actually exploited to support that research. And then finally, I think we all want to thank you for coming. We know it's like the last talk of the conference here, and it's great to see all these faces out there. We were worried there'd be only one or two of you, but thank you for coming, and I guess if there's questions.
Great.
You know, I can't talk fast.
Yes, thanks for doing that, and thank you all for coming. And thanks to everybody here that that spoke, and especially let me thank Lisa Feldman-Barrett, who really started us on this whole trek with the paper that was up here, and put in a huge amount of work into making that happen. So if you guys have questions, I guess all of us could come up here briefly and